Pre-calculus. In this video, we are going to discuss section 3.1 in chapter 3, rational functions. So what are rational functions? This is just going to be a ratio of two polynomials. Easy peasy lemon squeezy. So rational, of course, implies a fraction, and that's what a ratio is. And if you'll notice, I'm going to use our reciprocal parent function to illustrate some stuff to you. So most of this stuff will be stuff you remember from when we looked at the parent functions, but some of it's going to be new. And the thing that is going to be the newest to you is this asymptotic behavior right here. So I'm just going to quickly go through the fact that our graph does not cross the x-axis, and our graph also does not cross the y-axis, and that is why we have no x-intercepts and no y-intercepts. The horizontal asymptote, of course, is this line right here, which is the x-axis. Horizontal asymptotes are always equations of y equals because they're always horizontal lines. Vertical asymptotes are always vertical, so they go through the x-axis. The y-axis acts as the vertical asymptote. That's why it's at x equals 0. The domain, of course, is going to be all real numbers except for 0 because that's where our vertical asymptote is. Range, same thing because we have a horizontal asymptote at 0. Increasing. As you look at increasing and decreasing, remember that for these interval values, we always read the graph from left to right, meaning we look at what it's doing as we move our eyes or our pencil across left to right. If you'll notice, this is decreasing, and here it is also decreasing as we move from left to right. So it is not increasing at all. And we always use the x-axis, so decreasing is going to just be the domain. And our end behavior, remember, takes place here and here at our horizontal asymptotes. So x is approaching positive infinity in this direction, negative infinity over on the left, and it's all the y is always going to be approaching whatever the horizontal asymptote is. So as x approaches positive and negative infinity, y is going to approach 0. And our asymptotic behavior, let me switch colors here. Asymptotic behavior occurs here and here. Now, the thing you have to remember about asymptotic behavior is that the x is now approaching the same value. It's not approaching positive and negative infinity. Now it's approaching the same value. It's approaching 0. So x is approaching 0. Now we have to think about it as from the positive direction, so from this direction moving up, and from the negative direction moving down. So x is approaching 0 from the positive direction, and as it approaches from the positive direction, y is moving up to positive infinity, and as x approaches 0 from the negative direction over here, y is approaching negative infinity. So that's how that works. All right, so now let's transform that parent function of 1 over x into 1 over x plus 4. So we can see that this is transformed. So that means that, as you can see in the graph here, we're going to have a vertical asymptote at x equals negative 4. We still have a graph that is not going to cross our x-axis, so we have a horizontal asymptote at y equals 0. We do not have any x-intercepts because we have, I'm sorry, what am I doing? We don't have any x-intercepts because my graph isn't crossing the x-axis. My y-intercept, though, I do have it crossing right there. So that's going to be at approximately 1/4. And then, of course, my domain is going to be everything except for that vertical asymptote value. And my range is going to be, I'm out of control. And my range is going to be from negative infinity to 0 because of my vertical, or my horizontal asymptote, sorry. And then, of course, from left to right, this graph is not increasing, it is decreasing, and we, again, are going to use our domain. And our end behavior, remember, is right down here and over here. X, again, is approaching negative and positive infinity. Y is approaching the horizontal asymptote, which is 0. And for asymptotic behavior, the x is approaching -4 from the positive direction. That's happening right here because this is positive, this is negative. And y is approaching positive infinity. As x approaches -4 from the negative direction, y approaches negative infinity. Okay, so let's do another one. So for this one right here, I've got x minus 4 over x plus 2. So if you'll notice, I'm going to have a vertical asymptote here, and I've got a horizontal asymptote right here. So this one's a little trickier. Notice that the scale is different. This is a 10 right here. That means that each of these marks is worth 2. So I do have an x-intercept right here. That would be at 4, 0. And I have a y-intercept right here at what would be -2. And then, of course, I've got a horizontal asymptote. That would be at approximately 1 because it's halfway right there. And then I've got a vertical asymptote at x equals -2. My domain, again, my vertical asymptote is what's going to restrict me here. So that would be my domain. My range, my horizontal asymptote, is going to restrict me. Oh, that infinity is horrible. All right, so if you'll notice from left to right, this graph is now increasing here, and it's also increasing here. So now it's not decreasing, but it is increasing from negative infinity. Again, we're using the domain. And end behavior here and here. X approaches positive infinity, x approaches negative infinity. And what is y approaching? Y is approaching the horizontal asymptote at 1. And then here, x is approaching, let me change colors again. Here, x is approaching -2 from the negative direction. And y is responding by moving up, so positive infinity. Over here, x is approaching -2. From the positive direction, y is approaching negative infinity. So there's just an overview of 3.1.